elevator that I used was the elevator in Eller. Hi guys, I'm just going to be explaining how to calculate the different accelerations the, for the elevator project we did. Basically there's four. There's when you're stationary at the beginning, when you first accelerate up, and then when you're in a constant velocity, and then when you decelerate. And basically these, you're going to have a zero acceleration beginning, acceleration up, I added 0.955, then you get a zero acceleration again, and then when I decelerated it, I got an acceleration of negative 0.637. So I'm going to be explaining how to solve for the acceleration for the first two only. And yep. Okay, so for the first part of the elevator, I'll just have this little drawing out. So this is when it's stationary. So basically to figure out the acceleration for this, you already know. It's common sense. There's no constant velocity of zero. So that means acceleration is going to be equal to zero. So because of that, there's no acceleration, there's no net force. And that's because of Newton's first law. So we can say what happens here is I remain stationary and I don't go just fall straight through the ground. Is because of second law where there's a normal force, and the normal force is acting here, and it's when I have a force going down, which is my gravity due to force, and that would be my mass times gravity, and that would be 55.8, which is my mass, 5.8 times gravity, which is 9.8. And with that, I would get an answer of, let's see, 546.84 newtons, and that's my force due to gravity. So that would be me pushing down. We can say it's negative. This is negative, and then to cancel it out would be the normal force of the elevator pushing up against me, which would also be 546.84 because there's no acceleration, so there's no net force, so it keeps me stationary. Okay guys, time to find the second part, which is when the elevator is accelerating up. We know my weight, my mass is 55.8 kilos. My force due to gravity is 546.84, so now time to find the acceleration. So basically what I did was on the scale, now it changed. So it went from 123 to 135. And that little change was around 12 pounds, and I converted that to kilos, which was 5.44 kilos, and I converted that to newtons, and that was 53.31 newtons. So now all I have to do is use the formula I have, use equal to mass times A, Newton's second law. So this is my acceleration going up now, 53.31, equal to my mass. My original mass was 55.8 times A. So basically I divide that here, and I get my A. And that's how you get the acceleration, which is going to be 0.955 meters squared. And my net force is going to be 600.15 newtons. And that what accelerates you up.